working? Can you hear me? Yep. And Andre, do it quicker. Okay, we'll just do it from here. Okay, excellent. All right, well, thanks everyone. What I'm going to talk about this morning is a little bit about why continuous delivery is important and what business factors are driving it. And that will set up nicely some of the further discussions later in the day. So without further ado, because like all IT projects, we're behind schedule, yet we've got to make a series of milestones. So talk a little bit about what's driving this. So this is from a survey that we did in 2012. We've updated the survey, but the data is not significantly different. I've noted on the right-hand side where some of these trends are actually increasing. But the driver behind continuous delivery is that businesses and governmental organizations have the need primarily to increase the level of product capabilities much more quickly than they've done in the past. So this is driven by mobile applications, it's driven by cloud applications, and in turn the demands that those applications put on the rest of the organization and the rest of the information systems is significant. So it's forcing even the traditional systems of record to deliver at a much faster rate. That's primarily driven by increasing expectations from customers and the increasing rate of technology adoption across the industry. So we saw an announcement on Tuesday. Apple's got new wearable devices, they've got new iPhones that have some different capabilities, there's a new payment mechanism. So now organizations are, app developers are scrambling to take advantage of that. Organizations, especially in the financial industry around payments, are scrambling to take advantage of payment systems. I know you've had similar kind of mobile payment systems in Europe for quite some time. So all of these things together, these new technology opportunities, as well as the new business opportunities, is increasing demand for application delivery. And there's something else that's factored in here, and one is the changing workforce demographics. So as we see millennials entering the workplace, they work differently. They prefer a different way of interacting, much more collaborative. And so the style of development that's centered around agile and continuous delivery is very appealing to them. And to attract those sort of people to your organization, typically you've got to adopt these more modern practices. So all of these things taken together basically create a kind of perfect condition for continuous delivery to really add value. And one of the other factors, before I go on, is that we also see in traditional application development a lot of features and functionality developed that no one ends up using. And the longer the feedback cycle between when you start with an idea and when you deliver it, the worse that gets. So the other factor that we've seen in our research is that continuous delivery helps to cut down on the amount of features and functions that are implemented but never used, or implemented but aren't what the customer really needs. So by getting faster feedback, you actually eliminate a lot of waste in the system. And we'll talk more about waste in a little bit. I'll use this example from banking and do it quickly because I know that European banking is a little bit different. There's not as much focus on check deposit. So the point here is not mobile check deposit per se, but it's the speed at which a feature which was considered to be marginal or of relatively little interest to the broader banking community became dominant and became a way that banking organizations were chosen by customers. So USA Bank in 2009 released a capability to take a picture of a check and deposit that without having to actually send the check in. So this was largely based on overseas military people basically paying each other for bets and other sorts of things, gambling losses. And so everyone else in the industry looked at that, didn't seem very interesting. But by 2012, that 65% of consumers were willing to switch banks because of that mobile banking application capability. And today it's simply become something that in the US you have to have. So in roughly a 4-year, 5-year period, you see something go from sort of interesting toy to significant driver of business. And we've seen this happening throughout other industries with mobile technology. So there's a shift in mobile technology is causing a shift away from traditional retail, a shift away from traditional banking. It's changing all sorts of processes, and many of you are probably involved in making these sort of applications. But you think about how it's impacting your own personal lives as well. So the demand for mobile, as I mentioned earlier, is actually creating lots of demand for changing other kinds of applications more quickly. So sometimes people say, well, I don't develop mobile and cloud applications, so why should I be concerned with continuous delivery? But those mobile and cloud applications, unless it's a standalone game, it's not very interesting for consumers. So consumers are interested in accessing their corporate data or their government-related data, interacting with organizations through the mobile app, and that causes changes that have to be made to the services that the traditional applications offer. So those are being driven at a faster rate of speed as well. In addition, there's an increased complexity in the type of applications that one delivers. So in addition to the mobile applications, you have to coordinate that with the back-end applications, and you have to coordinate that with various other kinds of social media applications all at once. And so that coordination complexity that gets added is, in addition to, it's not just delivering a single app, but it's delivering these whole sort of family of applications and family of changes all simultaneously, and that increases the need for various kinds of automation as well as improved management techniques. So organizations aren't doing very well at responding to this. You know, most of us would probably think that updating, doing 2 to 4 releases a year of a mobile application isn't very good if we're, you know, from our personal consumer perspective. But that's about as fast as many organizations are delivering when we look at the data. It's improved a little bit over the last year, but not tremendously. So what we've seen is that, you know, organizations are somewhere between quarterly and monthly releases, even on their fastest applications, unless they tended to start web only or a cloud application, and those deliver at much faster rates. So what's holding them back are the internal processes, the organization structures, some of the technology, the culture. All of these things are conspiring to prevent organizations from delivering faster, and that's a lot of what you'll hear the speakers today talk about, is ways to remove those various kinds of impediments. So, as I mentioned earlier, the benefit of delivering faster is not just satisfying customer needs, although that's important, but it's also being more effective in the delivery of the functionality to customers. So by delivering faster, you eliminate waste from the application because you're not implementing things that people don't need. So you get faster feedback on whether something is important or not. And so in the cloud, we see techniques like A/B testing, which is used to basically evaluate usability factors and sometimes other deeper functionality factors. In mobile applications, we don't tend to see things like A/B testing, but we see other ways of validating functionality quickly and bringing that back in and affecting the development cycle. So the days of developing a big requirements document and then implementing that and then deploying that are gradually disappearing, in some cases quickly disappearing, and what we're seeing is people work on a constantly changing, constantly prioritized backlog that is driven by customer feedback and driven by the business priorities. So as the organization needs to shift, it shifts away from this kind of organizational structure, which is highly siloed or highly stratified, with teams organized by role, and then individuals in those roles assigned part-time to various teams. And we shift towards a more product-centric model where we see the team structure, the central team structure, as one where you have a cohesive team that works together. They're kept together, they're not disbanded after releases. They release a continuing stream of releases over time, and other parts of the organization align around them to support them. So instead of having people organized into silos where you might have a manager of all business analysts and a manager of all developers, we see a structure that looks more like people are organized into product teams that have cross-functional skills, and then they're also, in a sense, connected to a community which helps them to standardize practices and standardize things like job progression over time. So it's a more looser structure in terms of the professional role management, and it's a more cohesive structure from a product delivery perspective. So these changes affect people in different ways depending on their perspective and their role. So developers have to get used to delivering in relatively small batches. They can't be off on their own private branch for days or weeks, but rather need to deliver into the source code repository every day. That kicks off continuous integration, kicks off test automation, and kicks off automatic deployment into testing environments, and then eventually deployment into production environments. They have to do unit tests for everything, and that becomes the foundation for continuous testing techniques that then get carried throughout the life cycle. QA shifts from being a primarily manually oriented activity to one that's driven primarily off application programming interfaces, and it's driven by code. So the activities that a QA professional does in the future look much more like what a developer does today. In other words, they're writing code that tests other code, as opposed to executing manual scripts or even writing scripts that execute against the user interface. And the other part of QA is still doing manual testing, but they're doing exploratory testing and usability testing. So there's a split in the kind of staffing that you need to do for quality assurance. Architecture in the past has been, developers maybe rightly criticize it as being a kind of theoretical activity that's focused on big designs and lots of diagrams. And architecture needs to get much more integrated into the continuous integration process. And so the test automation that occurs is driving architectural tests as well as functional tests. And therefore the architecture of the application gets evaluated continuously as part of the continuous integration process. Operations also changes significantly. So this is very much about DevOps, and so it's a lot of the skills that developers have in terms of automating various kinds of processes get gradually taken into operations as well. So deployment automation, automating provisioning of environments, automating the testing, comparison between environments to make sure that you've not had a configuration drift between them. All of those things become very important, and it becomes much more embedded in this integrated development team, this integrated product team. So management, their perspective changes from managing top-down groups of professionals to becoming much more of an enabler. We speak sometimes of basically moving to a servant leader kind of model, where essentially their focus is to serve or to support the product delivery teams by removing obstacles as opposed to telling people what to do. This is a big cultural change for some managers. They're used to directing people, and that's not the model in this continuous delivery world. The model is very much based on agile practices and organizing around self-directing teams. So finally, the business has to change as well. So the big change for the business is that, first of all, they don't have today, in most organizations, a lot of trust that application delivery can actually work effectively. And so they have to gradually come to trust that deliveries will be frequent, the quality will be high, and then they start thinking differently in terms of how can I prioritize functionality to maximize the benefit of what I'm delivering right now. So that means that they don't, in the future, want to wait around for all of the functionality to be delivered all at once, but rather they need to think about what could we deliver first that might have value to somebody. Might only be a subset of the users, it might be only a subset of the user stories or use cases that the application supports, but they think much more in terms of time to market in the future, and then they work with the rest of the team to try to figure out how to meet the customer's needs in the best way. So it's a significant shift for the business, but it doesn't start to happen until the application delivery organization starts to deliver at faster cadences, and then the business starts to build the trust. So the way to transition to this process also isn't through a kind of big bang adoption where you sort of take, step aside, engineer the whole continuous delivery process end to end, and then implement it. But rather, it starts small by picking various things that you're doing now and improving those things and continuously improving over time. And a way to figure out where to improve is to use a lean manufacturing technique called value stream mapping to figure out what's your process today, how much time are you spending on activities in that process, and how much time are you spending waiting for those things to be able to be ready to execute. And so when I've done this with organizations, a big surprise has come that organizations spend more time waiting for something to be ready to work on than they do actually working on it. A telecom organization I worked with earlier this summer had 3 times the amount of time spent waiting as they actually did work. Now what's happening when they're waiting for somebody to do work, they go work on another project which maybe isn't critical, or they work on functionality that they think might be needed, but then they may find out later that it's not really needed. And in lean terms, what they're doing is they're creating a lot of work in process. And what happens when you get feedback is that sometimes that work in process gets invalidated. In other words, you have to throw it away. So traditional processes have a lot of hidden waste that can be eliminated if you can eliminate the wait time. And various ways of eliminating wait time. Some of it's through improving processes, some of it's through improving skills, some of it's through improving automation. But generally speaking, it's through improving all 3 of those, as Andre was saying. And so this lean value stream mapping approach is a good way to start thinking about this. And Andre mentioned earlier the book, The Phoenix Project. And really, what the Phoenix Project does is it basically talks about, in a kind of case study way, how you can apply these lean management practices to the problem of application delivery and software delivery. So it does it through an interesting way of engaging in the story, but when you really look at a lot of the principles, it's lean principles applied. So traditional benefits. Other speakers today will talk about the notion of infrastructure as code. And basically what that means is that we start treating the way that we build environments the same way that we do other kinds of software engineering. We establish configurations, and we build environments, and we provision those environments just like we're building software. So it's very analogous to the build process. And that reduces a lot of errors, especially the ones that you can characterize as it works fine in my environment kind of problems. And one organization that I worked with, they did an analysis of their post-deployment incidents, and they found that 18 to 20% of their post-deployment incidents were caused by non-code errors, in other words, by configuration errors. And so that, this is a tremendous source of essentially free resources, resources you can free up by being more effective, not just more efficient, but more effective at the way that you provision environments. You'll read in the Phoenix Project and hear lots of things today about this idea of big batches and small batches. And the idea is pretty simple, is that by driving very small units of functionality all the way through to deploying it to the customer, getting feedback, that's a small batch. The larger that incremental functionality is, the longer you'll wait to deliver it to the customer, and there's a greater potential that some of the things that you built won't be very useful to the customer because you spent too much time investing in building those things. So by reducing the batch size and by moving to more of a experiment, build, basically hypothesize, build, and get feedback, it's a more experimental loop, but you get better results. And so some of the terms around that are hypothesis-driven development is a big trend that's starting to come out now. Manual builds to continuous integration, manual testing to automated API-driven testing are key ways of accelerating this process and getting higher levels of quality. So we see as batch size reduces, as the cycle time reduces, that it's counterintuitive for many ops people because they think when you do releases, bad things happen. So therefore you want to do releases as infrequently as possible. But the reality is the smaller the release, the smaller the functionality in the release, the less risk, the easier it is to roll it back. And so risk declines as you go faster. And that's something that a lot of managers have to really, wrap their heads around and get and understand that better because it's counterintuitive. It's not something that you would think about. The key enabler to this is also loosely coupled services. So applications, instead of being large, monolithic, tightly integrated systems, they gradually evolve into being loosely coupled application architectures where you can replace any individual service or any individual component over time and not have to change other things. So moving to loose coupling ends up being a key enabler. So one of my other fellow analysts and I, we wrote a report last spring, and we identified these 8 different patterns in the ways that organizations deliver faster. And what we found is that this isn't really complicated. You know, this is actually a relatively small set of changes, but the implications of these changes tend to be large on organizations. And so, you know, I'll just summarize and talk about a few of these, and then we've got some time for questions. But the first thing is to think about your process in that lean flow example. Think about your delivery pipeline and where you have steps in that delivery pipeline that can be optimized, where you can eliminate wait time. The second step tends to be moving to smaller batches. And so for a lot of organizations, the key technique here is implementing agile project management practices, using agile teaming practices, using a backlog, delivering in sprints, and getting feedback, at least demonstration feedback from the business, if not deploying it to real customers. The third thing tends to be, you know, as soon as you start to do those agile practices, then you start to run into bottlenecks. It's very difficult to run a 2-week sprint cycle if you don't have continuous integration in place, if you don't have test automation in place, because you simply won't be able to sustain the effort. You can get a couple of sprints in, and then you find gradually that your productivity starts to flag, and you're not getting enough test coverage, and the whole thing falls apart. So continuous integration ends up being one of those key enablers, along with continuous testing practices, that enables you to drive the cycles much faster and do it sustainably. So the fourth thing is basically, as I just indicated, using continuous testing. So gradually building up those unit tests into deeper and deeper chains of functional tests, performance tests, throw in static code analysis into that, you know, start to get more and more feedback on every single build. So this is done gradually. You're not going to get complete 100% coverage overnight, but if you keep at it and build by build and sprint by sprint build this up, then you'll have a sustainable testing base that's tested as part of every single build. So the enabler for that ends up being loosely coupled architectures, because if you don't have the APIs to test against, then you can't really drive continuous testing. So adopting loosely coupled architectures, again, is something that for a new application you can do it from scratch or from the start, but for an existing application you have to build this up over time, gradually refactoring the existing application so that it has exposed APIs. And as you're doing that, as you're doing more testing, you find that eventually you can't provision the environments fast enough manually. And if you're not doing that as part of every build, if you're not provisioning the test environment fresh as part of every build, there's a risk that your test environments are dirty and they're not clean, they don't represent the production environment, and so you're not getting the kind of feedback that you want. So infrastructure as code ends up being key. All of these things taken together, if you're doing more testing as part of every build, you know the environments are solid, you're doing infrastructure as code, so the environments are under control, then that has the effect of eliminating the release drama, the big decision about, you know, where you pull everyone together and you ask them all, do you feel comfortable with this release? You don't have that anymore. You've got data on which you can base the release decision, and as many people who have been through this journey say, the releases become no big deal. It's not a significant challenge. So when you can do that, when you can release quickly and repeatably, then the business starts to change the way that they think about releasing, and they start to think about how can we do things in smaller increments. They start becoming more comfortable with ideas like the minimum viable product, which basically is what's the minimum amount of functionality that you can deliver to customers and still have that release be valuable. And that changes the way they think about strategy and execution. And then this whole cycle just keeps improving. So this is very much about continuous improvement as well as continuous delivery. So with that, I've got a little bit of time for questions. Let's see where we are. Yeah, about maybe 5 minutes or so. So, questions? Some of you probably look at this and say, this is really challenging. Some of you might look at this and say, yeah, exactly, that's what we're doing, and glad to see it validated. But where do you see some obstacles? Anyone? So the question of how do you change organizations? So this is a big thing, right? This is, even if we just go back to that slide that showed the organizational structure, going from that to that is a big thing. So it doesn't happen, we've never seen a pattern where organizations have changed the whole structure of the organization at once. Doesn't work. Don't try it. What happens, this change happens team by team. So you'll find a supportive business area who wants to work in a different way. You find supportive management who wants to be able to respond to that business area so that they can deliver faster. You find a market that's demanding faster delivery. And initially, that supportive management puts essentially some secure walls around that part of the organization, protects them from the rest of the organization, gives them the resources that they need, and typically that flourishes. And then you do that with another team and another team. And so it progresses team by team through the organization. There are some things that have, at some point, you get a critical mass of teams, and then the organizational staffing model has to change. And you have to move from the more center of excellence, siloed resource model to a different kind of teaming model. But that's usually when the number of teams that are working in this new way are, reach sort of the between 25 and 40% of the total number of teams. You have to start significantly changing. And along that path, executives or leaders are conveying the message that we're going to work in this new way. So that, once you've proven that this new approach works, which it does, and it's easy to prove if you support the teams, then the leadership says we're going to work in this new way, but not everybody all at once. And then you allow teams to self-select into that. When they're ready, they raise their hands and say we think we're ready to work in this new way, and they make a commitment to working in that new way. And it's very much in the patterns that we've seen for agile adoption. But it's incremental. The expectation I would set for organizations or executives when I talk to them is that this is conservatively speaking, a 3 to 5 year journey for the organization. It's not something that's going to happen in a year or even 2 years. And so, you should work incrementally and find the business areas where this can have the greatest contribution and support that, and then just really see how it goes. So, does that help? Yep. Other questions?
I actually have a question.
Yeah.
So on your this diagram where you talk about the integrated product team, you showed developers and IT operations, and today we see a very big trend in DevOps. Can you talk a little bit about what you see happening there, what your clients are saying they're doing, and what DevOps really means?
Right. And I mentioned earlier in the presentation that DevOps is a big part of this. And what DevOps means is that development and operations are working together in a concerted fashion to make the release process more smooth. So the specific practices that tend to be involved are things like infrastructure as code, deployment automation, automated testing, automated verification, things like compliance testing. So those are all more technical practices. But at a more practical level, it starts with developers and operations not hating one another, not thinking that the other person is the source of the problem. But we have a lot of stereotypes where operations thinks developers are, they produce shoddy code, it breaks in production, they're not very disciplined, and developers think that operations is too slow, and they don't provide environments quickly enough, and they always have lots of rules, and they're always saying no. And actually, in truth, both perspectives are a little bit right. But there are reasons behind it. So the first thing is to recognize that it's really, no one benefits until the customer starts getting value from the application. And so everybody has the incentive to make that experience as positive as possible. And then looking at that, using that value stream analysis to break it down, let's see where we are. So to break down, I think it was farther on, but to break down the barriers in that process to be more effective. So a lot of times it starts with very specific DevOps techniques that you'll hear about later today, but conceptually, first it just starts with accepting the fact that you all have the same problem and that development's not done when they deliver code to operations. And operations isn't done until basically you have a repeatable process for customers. Right. And I'll be around all day. We can talk more at lunch or afterwards if you want to have more of a specific discussion about any topic. Thank you. Merci.